Stuck in the pilot mode, why hospital AI doesn't scale in India, and why that's a procurement problem. Here's a number from the Healthcare AI Adoption Index 2026, a survey covering more than 400 healthcare stakeholders across providers, payers, and pharma. That should reframe how you think about every hospital AI success story you have read this year. Only 30% of healthcare AI pilots ever transition into production. Inside hospital systems specifically, the attrition is still sharper. The majority of the institutions running AI pilots today are, in the report's own language, trapped in repeated cycles of experimentation, validation, and stalled deployment, not because a single pilot failed once, but because the entire mechanism for turning a successful pilot into a permanent clinical tool doesn't reliably exist. Here is the sentence from the same body of research that this whole episode is built around, because it's the one that should genuinely surprise you. The researchers who conducted this analysis, talking directly to hospital CEOs, CIOs, and COOs across India, concluded explicitly that the answer to why this keeps happening is not technical, it's organizational. It sits, in their own words, at the intersection of leadership intent, data readiness, workflow design, and this is the phrase I want you to hold on to. I want to sharpen that even further than the report does, because I think the researchers are circling the real answer without quite landing on its most concrete form. This is not simply organizational maturity in some abstract sense. It's procurement. It's the specific mechanical, budgetary, and contractual machinery through which an Indian hospital decides to spend money on something, and that machinery built over decades for buying MRI machines and surgical instruments and hospital beds is structurally, predictably unsuited to buying continuously updated clinical software. A separate knowledge paper released by FICCI and Praxis Global Alliance in 2026, presented directly to India's Union Health Minister, names this explicitly as one of the exactly three core barriers blocking AI from scaling in Indian healthcare: inadequate reimbursement and procurement mechanisms, not inadequate algorithms, not inadequate clinical willingness. The same clinical report notes growing clinical acceptance, inadequate procurement. This episode is going to take that claim seriously and trace its all the way down to its mechanics. What specifically breaks, budget line by budget line, tender clause by tender clause, between a successful pilot demo in a hospital boardroom and a piece of AI software that is still running unremarkably 2 years later as just another part of how the hospital operates. Segment 1: The Symptom, a technology that works, a purchase that does not. Let's establish clearly and fairly that this is a genuinely not a primarily technology maturity problem anymore. Because getting that distinction right in the entire premise of this episode. Look at what Indian hospital AI actually has convincingly into a routine clinical use. Because the list is real and substantive, not vaporware. Ambient clinical documentation, AI systems that listen to a doctor patient consultation and generate a draft clinical note directly onto the EHR, has become, according to the industry tracking published in mid 2026, the most widely deployed clinical AI application in Indian hospitals today, where multi-site studies showing it cuts total EHR interaction time by roughly 30 minutes per shift and documentation time specifically by 16 minutes, while measurably reducing the clinical burnout. Digital pathology and AI assisted screening have moved in the same reporting from optional add-ons to what now is described as an expected capability for hospitals seeking empanelment with insurers and corporate hospital chains. Buyers without a digital pathology and AI roadmap as of 2026 reportedly being told by the procurement teams they won't be considered in the next tender cycle at all. Apollo Hospitals, India's largest private chain, has formally allocated 3.5% of their total digital spend specifically to AI over the past 2 years. This is not a sector where the core technology is unproven or where the clinicians are refusing to engage with it. And yet, the same reporting that documents these are real, working deployment is unambiguous that they remain the exception, not the pattern. The HIMSS AI landscape in the APAC Healthcare 2026 report found that it typically takes 2 to 3 years to put a single clinical AI model into routine use inside a hospital, even under favorable conditions. For Narayana Health, one of the largest private hospital networks and a genuinely sophisticated, well resourced digital health operator, building the underlying institutional foundation for AI deployment took not years but decades. If that's the timeline for one of the most digitally mature hospital networks in the country, you can reasonably infer what the timeline or the outright absence of one looks like for thousands of mid-sized and smaller hospitals that make up the overwhelming majority of India's healthcare delivery capacity. Here is the frame. Same discipline as every episode before this in the series. When a technology demonstrably works in isolation, well resourced pockets, and demonstrably fails to propagate outwards from those pockets at anything like the pace of its own proven value would predict, that propagation failure is itself the diagnostic signal. It tells you the bottleneck isn't in the technology's capability. It's in whatever institutional mechanism is supposed to carry a working pilot from we tested this and it helped to this is how simply we operate. That mechanism is procurement. And procurement, as this episode is going to show, was never designed for the kind of purchase clinical AI actually is. Segment 2. Mechanism 1. Capital budgets, buying and operating expense. The first and the foremost foundational mechanism is a budget category mismatch. And it is worth walking through carefully because it explains almost everything downstream. A traditional hospital capital purchase, MRI machine, a ventilator, a surgical robot, follows a well understood financial logic. A large one time capital expenditure, depreciated over fixed useful life, typically 5, 10, sometimes 15 years, after which the equipment is replaced. The procurement process built around this logic across virtually every Indian hospital, public or private, is optimized for exactly this shape of purchase. A tender is floated, vendors bid, technical specifications are compared against a fixed benchmark, a price is negotiated, the equipment is delivered, installed, and then critically, the financial relationship with the vendor is largely complete. Ongoing maintenance contract exists, but the core capital decision is a single discrete event. Clinical AI software does not fit this shape, and pretending it does is where the mismatch begins. A genuinely useful diagnostic AI model is not a static artifact purchased once and used unchanged for a decade. It is continuously retrained, updated, and refined against new data, new imaging protocols, and evolving clinical guidelines. It typically runs as a subscription or a usage based service, not a capital asset. Its ongoing value depends on sustained vendor engagement, model monitoring, drift detection, retraining as a local patient population characteristic shift, none of which resembles the buy once, depreciate over a decade logic the hospital's own financial system were built around. Here is where the mechanism actually breaks. Hospital AI pilots are funded through one-time budget categories, innovation grant, CSR allocations, a discretionary line in the CIO's annual digital transformation budget, sometimes a vendor subsidized proof of concept. All of those funding sources are by their inherent structure non-recurring. They fund a pilot beautifully. They are structurally incapable of funding what comes after a successful pilot because what comes after is an ongoing recurring operating expenditure, exactly the budget category Indian hospital finance departments, as per FICCI Praxis knowledge paper own diagnosis, does not yet have a standardized board approved mechanism for creating it. The pilot succeeds on its own terms. Then arrives a genuine institutional cliff edge. Continuing requires converting a one-time grant into a permanent line item in the next year operating budget line in the CIO's annual digital transformation budget. Continuing requires converting a one-time grant into a permanent line item in the next year's operating budget, competing directly against staffing, consumables, and the capital equipment requests the hospital existing procurement machinery already knows how to evaluate and approve. Most pilots do not survive that conversion, not because anyone in the room decided the AI tool doesn't work. They don't survive because the institution quite literally has no standing budgetary pathways built for exactly this category of recurring, evolving software as a service clinical purchase. And building that pathway requires finance committee level institutional change that a successful pilot on its own has no authority to trigger. Segment 3, Mechanism 2, L1 tendering for a product that is not a commodity. The second mechanism, and this one cuts even deeper into the actual procurement rulebook, particularly for public and government adjustment hospitals, through its logic bleeds into the private sector procurement culture as well. Government procurement in India for a very wide range of goods and services operates predominantly on what is known as L1 system. The lowest technically qualifying bid wins the tender. This system exists for genuinely good reasons. It's transparent, resistant to favoritism, auditable, and works well extremely for commodity purchases where the underlying product is functionally interchangeable across vendors. Bulk pharmaceutical supplies, standard surgical items, basic diagnostic reagents, and where the price is genuinely in the primarily differentiator once a minimum quality bar is cleared. Clinical AI is about as far as a commodity purchase a hospital procurement decision can get. And forcing it through L1 style evaluation produces exactly the kind of mismatch you will predict. AI diagnostic models addressing the same clinical use case, say, two competing chest X-ray screening tools for tuberculosis, can differ enormously in a way an L1 price comparison is structurally blind to. The size, the diversity, and demographic representativeness of the training data each was built on. The rigor and the independence of the clinical validation studies behind each. The model's actual false negative rate, specifically on the patient population profile of this hospital in this region, which may differ meaningfully from the population the model was originally validated against. The vendor's ongoing model monitoring and retraining commitment, and the vendor's willingness to accept meaningful liability exposure if the model underperforms in deployment. None of that shows up as a single comparable line item in the lowest bid tender format built to compare, for example, the price per unit of a syringe, the predictable consequence. And this connects directly back to the segment one's core observation is a systematic bias in exactly the wrong direction. An L1 structured procurement process applied to clinical AI tends to select the cheapest qualifying vendor rather than the most clinically validated one, precisely because the clinical validation quality is expensive to demonstrate rigorously and does not translate into a lower headline price. Often the opposite. A vendor who has invested heavily in a large scale, India specific, demographically representative clinical validation studies and who prices accordingly can lose a tender to a vendor offering a lower price with thinner supporting evidence simply because the evaluation framework was never built to weigh the difference. Some segments of the market are already adapting the pathology and radiology tender shift described in segment 1, where empanelment increasingly requires a demonstrated AI roadmap, shows procurement teams in private corporate hospitals starting to build quality weighted criteria into their vendor selection. But that adaptation remains uneven, concentrated even well-resourced private chains, and largely absent from the procurement culture still governing government and public hospital purchasing, where the L1 logic remains the structural default. Segment 4, Mechanism 3, no billing code, no revenue, no business case. And this is the one that converts an already difficult budget problem into something closer to a structural impossibility for many hospitals. There is currently no standardized mechanism under PMJ, under most private insurance schemes, or under standard hospital billing practice for a hospital to actually bill for and be reimbursed for an AI assisted diagnostic service as its own distinct clinical line item. Walk through what it means concurrently. When a hospital successfully pilots an AI-assisted radiology screening tool that measures improved diagnostic accuracy and catches cases a radiologist working alone might miss under time pressure, the value that tool generates is real, but it's diffuse, indirect, and largely uncapturable as direct revenue under the hospital existing billing architecture. The radiology report itself gets billed at the same rate whether or not AI assisted in generating it. The hospital cannot, in most current reimbursement frameworks, bill PMJ or a private insurer for an incremental amount of AI assisted interpretation as a distinct reimbursable service line the way it might bill separately for a specific lab test or imaging modality. The FICCI Praxis knowledge paper names this directly as a core barrier. The need for supportive reimbursement procurement mechanisms that can recognize the value delivered by AI-enabled healthcare technologies. Phrased as a forward-looking need precisely because the recognition mechanism, as of 2026, largely does not yet exist. This creates a genuinely difficult internal business case for most hospital finance committees evaluating whether to convert a pilot into a permanent budgeted service. The cost of continuing the subscription fees, the integration maintenance, the ongoing model monitoring are concrete, recurring, and easy to put a rupee figure on. The benefits: improved diagnostic accuracy, reduced clinician burnout, faster turnaround, fewer missed findings, all of which plausibly translate into a better patient outcome and indirectly but better institutional reputation and reduced medical legal exposure, are real but largely non-billable, diffuse across the whole patient population rather than attributable to individual billing encounters, and difficult to translate into a clean, quantified ROI figure. A finance committee evaluating competing budgets requests actually needs to approve a new recurring line item. Compare this directly to how a new physical diagnostic modality gets justified financially. A new MRI sequence capability, for instance, can be directly tied to a specific billable procedure code with a clear, calculable payback period based on the expected patient volume and the reimbursement rate for that specific code. Clinical AI, lacking an equivalent billing code in the overwhelming majority of cases, simply cannot be justified through the same financial logic, no matter how strong its underlying clinical evidence is. It's not that the hospital finance committee don't value better diagnostic accuracy. It's that their own approval process are built around a reimbursement architecture that currently has no slot for pricing that value directly. Segment 5. Mechanism 4. Nobody wants to sign the liability. Fourth mechanism, and this one operates less through budget mechanics and more through institutional risk aversion at exactly the moment a pilot needs a senior decision maker to formally sign off a permanent deployment. Scaling an AI pilot into routine clinical use at some point requires a specific person or committee inside the hospital, a medical superintendent, a chief medical officer, a clinical governance board, to formally authorize the tool's ongoing use in actual patient care decision, not merely its use in a bounded, closely monitored pilot. That authorization decision runs directly into a genuine, unresolved regulatory and liability question this podcast has touched on before in the accreditation and DPDP episodes. If an AI diagnostic tool contributes to a missed diagnosis or a clinical error, who bears the responsibility? The treating physician who relied on the tool's output, the hospital that deployed it, or the vendor who built it? India's regulatory framework, software as a medical device under CDSCO, is actively developing and refined. But the FICCI Praxis knowledge paper notes explicitly the absence of a predictable life cycle based regulation for adaptive AI. Regulation that can account for model that continues learning and updating after initial approval, rather than a static device approved once and never changed, remains a unresolved barrier as of this recording. Put yourself for a moment in the position of a hospital chief medical officer being asked to sign off on a permanent deployment of an AI diagnostic tool under these conditions. The pilot data looks genuinely promising. The vendor is credible. The clinician who used it during the trial period was enthusiastic. And yet, the regulatory pathway that would clearly establish the tool's approved clinical status defines exactly what liability the vendor assumes versus what liability that transfers to the hospital and the treating physician, and provides a clear, defensible audit trail if the case is later challenged. that pathway is still maturing, still ambiguous in the exactly the ways that matter most when something eventually goes wrong. Signing off on scale in this environment isn't simply endorsing a technology. It's personally and institutionally accepting a liability exposure whose exact contours nobody yet can fully specify. The rational, predictable institutional response to a genuine, unresolved liability ambiguity. And this mirrors exactly the incentive logic this podcast applies to hospital administrators, private equity investors, and resident training institution in earlier episodes. Is not a reckless deployment and not principled refusal. It's indefinite deferral. Keep running the pilot. Keep collecting more data. Keep the tool in a supervised, bounded trial status where any error can be caught and corrected by a human clinician who was never asked to rely on the tool's output, only to consider it. That deferral looks from the outside exactly like getting stuck in the pilot mode. From the inside, it's rational response to a genuinely regulatory and liability vacuum that no individual hospital administrator has the authority to resolve on their own, no matter how much they might personally believe in the tool's clinical value. Now, the Steelman, same discipline as every prior episode of this series. First, some pilots genuinely should not scale, and treating every stalled pilot as evidence of procurement failure would be intellectually dishonest. Segment 1 already established that a technology genuinely works in specific, proven use cases like ambient documentation, pathology, and radiology screening. It does not follow that every AI pilot deserves to scale. Some fail on legitimate clinical validity or workflow fit ground that have nothing to do with the budget categories or tender rules. A procurement system that filters out genuinely weak pilots alongside genuinely strong ones is not purely dysfunctional. Some of that filtering is exactly a cautious, patient safety conscious institution should be doing. And rushing every promising pilot straight to scale without that caution would create its own serious risks. Second, the ecosystem level foundation generally is being built and building in the right order. Foundations before mandates is a defensible sequence choice, not evidence of neglect. The FICCI Praxis knowledge paper presented directly to the Union Minister explains framework that current moment India having built strong foundation on. ABDM, the India AI mission, the National Medical Device Policy, while still working through exactly the scaling barriers this episode describes. That's a materially different, more hopeful situation than a country with no foundation and no roadmap at all. Naming the procurement and reimbursement gap explicitly in a paper delivered to the health minister is itself a sign the barrier is now visible to policymakers in a way it may not have been 2 years earlier. Third, and this is worth real emphasis, outside healthcare specifically, Indian enterprises are not lagging in AI adoption broadly. Deloitte's 2026 State of AI in Enterprise report found Indian organizations leading globally in a scale AI deployment across functions like product development, operations, supply chain, with 40% of Indian respondents reporting significant or full AI usage against a roughly 28% global average. That matters for this episode's argument in a specific way. It suggests the barrier genuinely is sector specific to healthcare, particularly procurement, reimbursement, and liability structure, rather than reflecting some broader Indian institutional incapacity to operationalize AI at all. The country clearly has organizational and technical capability to scale AI effectively when the surrounding incentive structure supports it, which strengthens rather than weakens. This episode's core claim that the healthcare specific procurement mechanisms are actual bottlenecks. So, the honest landing point, procurement, reimbursement, and liability ambiguity are genuinely the domain bottlenecks, exactly as the FICCI Praxis paper and the healthcare AI adoption both independently conclude. But the appropriate response is targeted mechanism redesign, not a wholesome indictment of Indian hospital administrators as uniquely resistant to innovation. They are responding rationally to a set of institutional incentive nobody has yet designed for this specific category of purchase. Segment 7, the blueprint, redesigning procurement for software that learns. 5 structural shift each targeted directly onto the mechanisms diagnosed in segment 2 to 5. 5 structural shift. Each target directly at one of the mechanisms diagnosed in segment 2 through 5. 1. Create a distinct board approved recurring operating budget category specifically for clinical AI and other software as a medical device, digital health tools, separate from both one time innovation grants and traditional capital equipment budgets. This directly addresses segment 2. The cliff edge between the pilot funding and production funding disappears once the hospital finance committee have a standing pre-approved pathway for converting a successful pilot into an ongoing line item rather than needing to build that approval from scratch. Ad hoc every single time a pilot succeeds. 2. Replace L1 lowest bid tendering for clinical AI procurement with outcome weighted, quality adjusted evaluation criteria, explicitly scoring training data representativeness, independent clinical validation evidence, local population performance data, and vendor liability commitments alongside price, not instead of it. The pathology and radiology sector shift towards AI roadmap conditioned empanelment described in segment 1 is a working template. What's needed is a formalizing that shift into standard procurement policy, particularly for government and public sector hospital tendering, still defaulting to the pure AI logic. 3. Working with PMJ, CGHS, and major private insurers to establish defined billing codes for validated AI assisted diagnostic and clinical decision support services tied to CDSCO SAMD approval status. This directly closes segment 4 gap. Once a hospital can bill and be reimbursed for AI assisted interpretation as its own distinct service line, the internal financial business case for permanent deployment becomes concrete and calculable in the exactly the same way capital equipment purchases already are, rather than resting on diffuse, hard to quantify quality benefits alone. 4. Accelerate and clarify India's life cycle based regulatory framework for adaptive AI under CDSCO, with explicit published guidance on liability allocation between vendor, hospital, and treating physician for CDSCO approved tools used within their approved scope. This is a direct answer to segment 5. A hospital medical superintendent asked to authorize permanent deployment needs a clear published liability framework, not an ambiguous regulatory landscape they are personally exposed to if they sign off and something later goes wrong. 5. Build standardized, publicly available pilot to scale evaluation criteria. A genuine graduation checklist a hospital innovation team can run any successful pilot through, covering workflow integration evidence, clinical adoption data, local population performance validation, and total cost of ongoing operations, so that the decision to scale or not to scale is made against a consistent institutional standard rather than depending on how persuasive an individual pilot champion happens to be in front of a given finance committee. This directly targets the outcome measurement discipline, the GAP AI Healthcare Adoption Index, named as central to the problem. None of these 5 require slowing down the genuine technological progress already underway. They require treating the purchase of continuous learning clinical software as a structurally distinct category of institutional decision it actually is, rather than continuing to force through a budget categories, tender rules, and liability frameworks built for a different kind of a purchase entirely. An AI tool that cuts documentation time by 16 minutes a shift, or catches a tuberculosis case a radiologist working under pressure might miss, doesn't fail to scale because the algorithm stops working outside the pilot ward. It fails to scale because the institution around it was never given a recurring budget line to keep paying for it, a tender process capable of recognizing what made it worth paying for it in the first place, a billing code to recover its value, or a liability framework clear enough for someone senior to feel safe signing their name to a permanent deployment. This question, this episode leaves you with, matching with the shape the 5 before. What would it take for a successful hospital AI pilot in India to graduate into a routine use as a matter of standard institutional process, rather than depending, as it currently does, on a handful of well-resourced hospital patiently building, one by one, the procurement infrastructure the rest of the system will still doesn't have? Cut. An AI tool that cuts documentation time by 16 minutes a shift, or catches a tuberculosis case a radiologist working under pressure might miss. Doesn't fail to scale because the algorithm stops working outside the pilot ward. It fails to scale because the institution around it was never given a recurring budget line to keep paying for it. A tender process capable of recognizing what made it worth paying for it in the first place. A billing code to recover its value, or a liability framework clear enough for someone senior to feel safe signing their name to a permanent deployment. This question, this episode leaves you with, matching with the shape the five before. What would it take for a successful hospital AI pilot in India to graduate into a routine use as a matter of standard institutional process rather than depending on a handful of well-resourced hospital patiently building one by one the procurement infrastructure the rest of the system will still doesn't have? That's it for this episode of Let's Break In. If this changed how you read the next hospital launch AI pilot headline, that's good. That's the whole point. Drop your take in comments and find me on LinkedIn. I read everything.